In this video, we're going to talk about how to solve system of linear equations in 3 variables. So we're going to start with this example I have shown here. But before we actually dive in and start doing this, I want to talk about what our goal is going to be. So we're going to be using elimination to begin with. So let's go ahead and talk about the goal first. So the goal is to first convert to triangular form. Okay, so we want to convert our 3 equations to look something like this. This is triangular form. Notice how this one involves x, y, and z, and this equation involves y and z, and then this equation involves only z. So your equations are involving less and less variables as you go down. Okay, all these other letters are just constants. Don't worry, they're just other constants. But notice that there's a leading 1 in front of the x. Okay, and leading 1 in front of the y, and leading 1 in front of the z. So there's no number out there. Okay. In order to be able to do this, there's legal operations you're allowed to do. The first is that we're going to be allowed to add non-zero multiples of one equation to the other, and you'll see what that means in a minute. And then also multiply equations by non-zero constants and interchange positions between 2 equations. These are the 3 things we're allowed to do. Not allowed to do anything else. And once we have, so the reason why this is the goal is because once we have our system of linear equations in this sort of format, then we can use back substitution. This will tell us what z is, plug that in here, figure out what y is, plug those 2 in here, and we can figure out what the x is. Okay, so let's go ahead and we'll get started with that example I showed there in the beginning. Okay, so the very first thing that we need to do is make sure that the first equation involves x, y, z, and the leading coefficient is 1. So the first equation in this system is already good to go. Second equation should not involve x. Okay, so we need to eliminate x. I'm going to go ahead and make that a little smaller so I'm going to have enough room because this is going to take a lot of steps here. So the first thing I'm going to do is try to eliminate x. So to eliminate x, I'm allowed to add non-zero multiples of one equation to the other, right? That was one of the things I'm allowed to do. So if this is equation 1, and this is equation 2, and this is equation 3, what I'm going to do is I'm going to do equation 2 minus equation 1, which is basically the same thing as adding a non-zero multiple because I'm adding -1 times the first equation. Okay? So, and then if I do that, I'll eliminate x, which is my goal. So that's going to be the first thing I'm going to do. So the second equation is x plus 2y minus z equals 13. Okay, now I'm going to multiply everything in the first equation, or E1, by -1. So I'll have minus x plus 2y minus 3z. Don't forget to do it to both sides of the equation. So that would be -1 instead of +1. Okay? So this is E2. This is -E1. Alright. These cancel. That's the goal. That's why I did it. And then we'll have 4y minus 4z equals 12. Alright? I need this to also have a leading 1 in front of the y. Remember, so we should have a leading 1. So now we only have y and z, which is great, but I need that 4 not to be there. So I'm going to divide everything by 4 to get y by itself. So this will just be z, and then 12 divided by 4 is 3. Okay, so now I've changed my system to be, so I have still this x minus 2y plus 3z equals 1, but the second equation is now y minus z equals 3. And I haven't done anything yet to the third equation. Okay, so let's deal with the third equation. So the third equation needs to eliminate x and y. It needs to only have z in it. So that's going to be our next step. So to do this, let's eliminate x. So to do that, I'm going to do the third equation. I'm going to subtract off 3 times the first equation. Okay, if I do that, then I'll have negative 3 here, and then these will cancel. So I'll get rid of the x. Okay, so I'm going to go ahead and do that. Alright, so the third equation is 3x plus 2y minus 5z equals 3. Okay, and then I'm going to do negative 3 times each part in the first equation. So negative 3x plus 6y minus 9z minus 3. Okay, so let's write that down. Negative 3x plus 6y minus 9z equals negative 3. Okay, be really careful with your signs here. It's very easy to make a mistake. So the 3x and the 3x, they cancel. Then we have 2y and 6y, which makes 8y. And then minus 5 and minus 9 is minus 14. Z, and then these two cancel, and you're left with 0. Okay, so now the next thing that I'm going to need to do is eliminate y. Okay, so this is my new equation 3, and I need to eliminate y from it. So to do that, I'm going to take my equation 2, this equation 2, my current equation 2, and I'm going to multiply that. So I'm going to, let me write this out. So I'm going to take equation 3, and then I'm going to subtract off 8 times equation 2. Okay? So that should work because we have 8y here, and then there's just a plain y here. So if I do negative 8 times it, then these will cancel. Okay? So let me go ahead and write that. So I'm going to write my current equation 3, which is 8y minus 14z equals 0. And then I'm going to do, and I'm looking up here, I'm going to multiply negative 8 by each term. So this will be negative 8y plus 8z minus 8 times 3 is 24. Okay, so let's go ahead and write that. Minus 8y plus 8z equals negative 24. Okay, so these cancel. This is negative 6z equals negative 24. So z, then, if you divide both sides by negative 6, z equals 4. Alright, so now this is my new equation 3. Okay, so now I have the triangular form. So I'm going to write that here. So this, I'm going down to my next step. So I still have the first equation, 3z equals 1. The second equation, minus z minus x, or sorry, y minus z equals 3. And now this new third equation is z equals 4. Okay? That's in triangular form. So now I just need to do back substitution to find all the variables, okay? So I'm going to do that down here. So I'm going to plug in z equals 4 to the second equation. So I'll have y minus 4 equals 3. If you add 4 to both sides, you get y equals 7. Okay, then go up to the first equation to figure out what x is. So x minus 2 times 7, y is now 7, plus 3 times 4 equals 1. So x minus 14 plus 12 equals 1. X minus 14 plus 12 is minus 2. So add 2 to both sides, x equals 3. Okay, so how do you write your solution? So it's a point, but it has 3. So you go x, y, and then z. And there you go. That's your solution. This video is getting kind of long, so I'm going to go ahead and start a new video to do more examples.